Alright, you 12s. So this week, Wednesday, Thursday, Friday, the aim is to just recap your Year 11 derivative skills. So you got your power rule, chain rule, how to derive exponential log functions, circular functions like tan of x, sine of x, cos of x, um, and if I can squeeze in product rule, I will. But looking at the time, I don't think I can. Given the number of videos I need to upload, it takes a while to upload. So I think that will set you up. Technically, that's like exercises 9B all the way to J. That's the exercises. Now I've put up the chapter 9 questions or set questions, so you can look at the questions and you pick and choose which one you want to do. But remember, all I want you to take out of it is knowing how to derive each of them again, because you've done it in year 11. Your aim is to revise or just revisit those skills. Now, back in the holiday folder, I actually had some calculus revision. Actually, I'll show you. So many files here. Okay, so in the orientation, if you have a look down here for new students in 2015, I actually covered the derivatives, and these are the worksheets. Now, if you want more practice besides your exercise book, I'd say use these revision sheets that we did last year. They will help you much better than your textbook. Your textbook is probably assuming that you already know it. So these are year 11 techniques, and you can do these first before you do the exercises. Otherwise, you can do the exercises as well. There's no problem there. Okay. I guess in this short time, when I come back, I'll probably then try to get you to remember what the derivative really means. So a lot of the questions I'm choosing right now are just skill-based. Okay, they're just methods. They're not really getting you to think, well, what does it mean? I'm not getting you to interpret the gradient function yet. When I come back, I want to make sure that you understand that. But for now, I'm just going to teach the skills. So I do a lot of examples, and you can always review the example, see if you pick up the skill. Okay, so the first one that we are doing is the power rule. Okay, so let's have a look at the power rule. These are your power rules. Exercise 9B, C, and F is a power rule problem. So, just to remind you what the power rule was, power rule says that if you have y equals to ax to the power of n, so it's a polynomial, x to the power 2, that's what n would be, x to the power 3, that's what n would be. Then when you find the derivative, then dy dx, which is the derivative or the gradient function. Remember that. If you were in my class last year or start of year, I mentioned about the gradient function. So this is n times a. So what I've done is I've brought the power down, n times a times the x to the power of n minus 1. This is called your power rule. Okay. So how does that apply to these examples here? Let's say I take, I'll take this one. This one looks long, so you can see. Okay, let's take each one of those and do them individually again. So last year, if you weren't paying attention and you were doing your biology, this is the time to redo power rule. So 5C, you've got y equals to 5 times x to the power 3 minus 3x to the power of 2 plus 2x technically to the power of 1, even though you don't write it, and then plus 1, technically it's x to the power of 0, even though you don't write it, because x to the power of 0 is 1, right? See how I wrote it out just so that you could see how we're going to use this rule over here. Okay, so here we go. Same deal. Dy dx will equal to, bring the power down, so that's 3 times 5 x to the power 3 minus 1. You see how I'm just following the rule over here. Nothing new. Same thing. Nothing crazy, yeah? And then same thing over here. I know that's a minus sign, but what I'm going to do is I'm just going to say plus. Okay, because the plus doesn't affect it. What I'm going to do again, I'm going to bring the 2 down. So that becomes now 2 times negative 3. See, that's why I kept the negative there instead of plus here. So that's my negative 3x to the power 2 minus 1. You see, I'm still using the same rule. Nothing different. Nothing changed. So plus again. And now what I'm going to do is I'm going to say, alright, I'm going to bring the power down. I'm just using the power rule. Because what the hell is this? So I'm just using the power rule. I'm just bringing down 1. And then same thing again. 1 times. The a is the number in front of x. So right now it's 2. So 2x to the power of 1 minus 1. Okay? And then I'm still doing it again. Plus. Bring the power down, and that now becomes 0 times 1x to the power of 0 minus 1. Okay, now we're going to simplify all of this. Each one of these will have its own sort of value. So 3 times 5 is 15, x to the power of 2, 3 minus 1 is 2, and then this is technically 2 times negative 3 is negative 6, so minus 6 x to the power of 1, because 2 minus 1 is 1. And then notice this is 1 times 2, which is 2. But x to the power 1 minus 1 is 0. But x to the power 0, hopefully you remember, anything to the power 0 is 1. So technically it's 2 times 1, which is 2. And then finally 0 times anything is 0. Okay, which makes sense because remember, when you find the derivative, you find the gradient. Now you look at this. This is y equals 7. That's just a straight line that looks like this. It's just a horizontal straight line at 7. What's the gradient? Well, we know that horizontal lines have a gradient of 0 back in year 9 maths. Yeah? It's a gradient of 0, which is why I know the derivative of 7 is actually equal to 0. I mean, you can use the power rule if you wanted to. It'll be just like doing the power rule of 1, because I'll just write 1x to the power 0. Yeah? And that just works out to be 0. So that's how you find the derivative for a power rule. That's what the power rule is. That's, you're just playing around with that same idea over and over and over. Okay? Now, the question is, well, what happens when you get brackets? You know, like these, for example. The only way to do it is you have to expand it. You have to get your individual terms. These are called individual terms. See how they're all separated by a plus and a minus sign? Those are called individual terms. Okay? You need to expand them out. So same thing with this one. You'll need to expand the brackets there. Now the one that might be tricky is G and H. Okay, G and H. Now I'm going to erase all of this because it lags when I have too many of these symbols on it. So I'm going to remove it all. Remember, this is a video. You can always return and replay the same thing again. So I'm going to erase it all. I'm going to do G now. I'm going to get you to do G to C. Look, G. Most of the time, if they give you a fraction, it's either a quotient rule problem, which means division problem, or a power rule problem. That's the only two types. But since it's exercise 9b, it's got to be a power rule problem. Means that you can simplify this problem before you even evaluate it. A lot of people do this mistake in year 11, which I'm going to assume is going to carry into year 12. This is what they do. They say, oh, right, so you got 10x7, so they pull down the 7, so now it becomes 7 times 10 x to the power 7 minus 1. They bring the 2 down, and that's plus 2 times 2x to the power 2 minus 1. And then they bring the 2 down for this one, and that becomes 2 times x to the 2 minus 1. Simplify each one of them, and that becomes 70x to the power 6 plus 4x to the power of 1 over 2x to the power of 1. And the right answer is that. Okay, terrible. Because we already told you that the formula, the power rule, only works if you have this. They didn't say if you had that. They never said that. They never said. I'm pretty sure I said from the beginning, this is your rule, and if that is your rule, then it's dy dx is equal to n times a x to the power of n minus 1. I have no idea why you're able to do that. Okay, that's a rule that you made up. It doesn't make sense. So the only way to solve it is if you simplify it so you get individual terms, as we're saying. See, those are all ax to the power of n. All ax to the power of n. This is not ax to the power of n individually. That's a fraction. We don't know how to do fractions. The rule doesn't tell you to work with fractions. Okay? So, how do we do the problem? Very simple. This is what we're going to do. So, same thing with g. We're going to split that fraction. We're going to split that fraction. And we split the fraction. What you'll see is y equals, instead of leaving it as a included fraction, I can write it like this: 10 to the power of x on 7. Remember, denominator is x squared, so you can split it. You can say that's x squared plus 2x squared on x squared. There's nothing different. I've just split it up. Back to grade 3 and 4 mathematics. Splitting fractions. Yeah, same denominator. You can split the two out, or you can group them together. Now, the beauty thing is you can actually simplify the problem. X to the power of 7 divided by x squared. If you've forgotten your exponentials, year 8, year 9 maths here, you got x to the power of 7 take away 2. Or you can think about it as, if you got x times x times x 7 times, and you got x times x at the bottom, you divide them, 2 of them will be missing, so you got x to the power of 5 left over. So these two will cancel out, and you'll be left with x to the power of 5. So this now gives you 10 x to the power of 5. This one, on the other hand, is x squared divided by x squared, which we know is 1. Okay? And so that now gives you plus 2. And voila! You're back to the simple problem. Again, you got y equals this, so if I want you to find dy dx, it is just bring the power down, 5 times 10, x to the power 5 minus 1, plus, same thing again. This is the same thing as writing x to the power 0. Bring down the 0, and then 0 times 2 x to the power 0 minus 1. But we know derivative of any constant, any number, see that's a number, is going to be 0 because you always got that 0 power there. 0 times anything, 0. Whereas this one, that's just 50 x to the power 4. Too easy. Okay? And so if I looked at h, if I quickly look at h, then with h is the same idea. I just look at it and I say, oh, well, I can cancel out the x's. And so cancel the x with this, that becomes cube. But remember, you have to cancel out this one as well. So this now changes the problem to y equals 9x cubed plus 3x. And you want to find derivative. I want to quickly, instead of, bring down the power, this now just gives you 27x squared plus 3. Okay, so I'm doing that in my head now, and hopefully you're keeping up to speed with the technique I'm using. Okay, it's just the one technique, PowerRule. Alright? Cool. Let's do something a bit harder with different powers or negative powers and whatnot. So, exercise 9C, you're still using PowerRule. They've just played around, they've put more fractions in, and they've put negative powers in. So, same thing, I'm going to do, oh, whoops, it's this one. So if I do A, let's have a look at A. Same thing, nothing crazy, okay? So, A, I'm going to speed it up now, I'm going to drop down the power, remember that's a constant, so it's going to be 0 when we find the derivative. So, dy dx will equal to, bring down the power, it's negative 2 times 3 x to the power of negative 2 minus 1 plus, same thing again, I'm going to drop down to negative 1, so negative 1 times 5, and it's x to the power of negative 1 minus 1. But I know the last derivative of any number is going to be 0, so I don't need to write it down, okay? So working that out, that just gives you negative 6 x to the power of negative 3, and then you've got negative 1 times 5 is negative 5 x to the power of negative 2. But you remember anything I taught you last year? Never leave your answers with a negative power. So you should write your answer as a positive power. And I know some of you aren't really good with your indices. x to the power of negative 3 is the same thing as writing 1 over x to the positive power of 3. So instead of having a negative power, if you want it to be positive, you just do the reciprocal. Okay? So that means you actually now have negative 6. This is times 1 on x cubed, which really, another way of writing it is just negative 6 on x cubed. Okay, so same thing with this one. This would be minus 5. That's times right there. So that's 1 on x squared. So if you know about fractions, 5 is a whole number. So if you write it, it's like 5 on 1 times 1 on x squared. So of course, 5 goes with 1, 1 goes with x squared. So you get x squared. So that just makes it minus 5 on x squared. That's a more preferred answer than this. Don't leave your answer there with negative powers. Okay. All right. Let's pick another one that looks tricky. Let's do B. B. I have a feeling that a lot of people are gonna mess up with B if they weren't good with the indices. So 5x cubed plus 6x squared. Yeah. Well, 6x squared derivative, that's pretty easy. It's this x cubed, but I just told you. If it's on the bottom, you can bring it up. But if you bring it up, then you're going to get a negative power. So another way of writing this is, you can write it as 5x to the power of negative 3 plus 6x squared. Okay? And then you can then say, all right, well then the derivative must be dy dx. Bring down the power, negative 3 times 5x to the power of negative 3 minus 1. Plus, bring down the power, 2 times 6x to the power of 2 minus 1. And that gives you negative 15x neg 4. And then that's plus 12x x. Okay? Don't leave your answer with negative power. So your answer would be negative 15 on x to the power of 4 plus 12x. Okay, so that's for B. If some of you hate fractions, you'd probably be intimidated by question E right now, and you shouldn't be. It all goes back to your basics, your index laws and whatnot. So I'm going to do E just so that you get an idea. Same thing. See, if I'm going to do E, wait, let me just erase it all again so it doesn't lag. So here we go, E. Let's do E. So with E, same concept. We've got y equals to 4x squared plus 2x over x squared. Yeah, split up the fraction. You know, just go back to your basics. You know, you just split it up. It becomes 4x squared over x squared plus 2x over x squared. Now, when we're simplifying indices, what you got to realize is x squared. This is all time, so you can actually cross simplify. It's fine. So this is x squared divided by x squared. So you can say how many x squares and x squares. Or another way of thinking about it is x squared is the same thing as writing x times x over x times x. You split those two fractions up, it's x over x times x over x. Now we know x divided by x is 1. X divided by x is 1. That's why it all cancels out to be 1. Okay? So that's why you only left 4 times 1 is just 4. Okay? Plus, and then again, if this confuses you, same thing, you can write it out. Like, split it up. This is just x over x times x. You can split that fraction up and write it as x over x times 1 on x. That's the same thing as writing x over x squared. You see how I'm just breaking it out back to year 8, year 9 maths here. I'm just breaking the x squared in that. And this is year 3 mathematics. So if you look at it, x divided by x, we know it's 1. So 1 times 1 on x. This simplifies down to 1 on x, which is why it's just 2 on x. So if you had to find or rewrite 2 on x, see 2 on x, you can rewrite that as, this is power of 1, you can rewrite that as 2 times x to the power of negative 1. Why? Why is that? Because you can break this apart. You can write it as 2 times 1 on x. True? Yeah? 2 times 1 on x is the same thing as 2 on x. 1 on x is the same thing as writing x to the power of negative 1. That's why I've got that. Okay, so this really just rewrite it as x to the power of -1. Okay, all I did was just rewriting it. Now you can find the derivative using the power rule. The power rule, very straightforward. That's a constant. So the derivative of a constant is always going to be 0. Okay, and then derivative of this, bring the -1 down. -1 times 2, x to the power of -1, take away 1. Okay, and that just gives you -2 x to the power of -2, but don't write your answer with a negative power. -2 over x squared. Okay, and that's how you do it. That's 9C. Now let's have a look at 9. What's the next one? 9C. Oh, so same drill. Same drill as what I was trying to show you before. Split the fractions up. Split them up. Every one of these, you can split them up. It becomes 4z over z squared plus z cubed over z squared minus z to the power of 4 over z squared. And you can simplify that. And you can then use the power rule. Okay, so none of these are hard. Don't be intimidated by fractions. I know we suck at fractions in general, but you got to get used to them. You got to practice. You got to goes back to the basics, and that's what I always said. Your basics suck, everything goes down. Okay, so you just got to be able to work with these index laws and exponential laws and log laws and whatnot to really do derivatives well. Okay, because the power rule wasn't hard. It's just when you put fractions in negatives, it tends to get students. Alright, so let's see, 9F. Same thing. The power rule applies because we said it was y equals a x to the power of n. Now, n could be anything. It could have been a negative number. It could have been an integer. It could be a rational number, which in this case is a rational number. It's a fraction. Okay, and it still applies. So if I wanted to do this, it will be the same thing. A x to the power of 1 of 5. So bring the power down, and that gives you dy dx equals to 1 on 5 times x to the power 1/5 minus 1. Okay, and I know the answer is 1/5 x to the power 1/5 minus 1. Hopefully we can figure that out. That's -4/5. Okay, and so don't write your answer as a negative power. It would be much better to write your answer as 5x 4 on 5. Now I know this is one of the things as students, they skip steps. Now I'm going to show you why this stays together. Okay, there's a lot of times students, for some reason, they mix everything up. They just get it wrong. Remember, write what you see. This is 1/5 times x. I'm going to write it out. So it's 1/5 times x to the power -4 on 5. We know that if it's a negative power, you can rewrite it as 1 over the positive power. So it'll be x to the power 4 on 5. You see, it's very simple. And then when you multiply it, 1 with 1, 5 with that, that's why I've got the answer as 1 over 5 x to the power 4 on 5. Okay? Yeah, there's some tendency for students like to just flip numbers for the sake of flipping numbers. You see, I'd never just flip it. I've got a reason why I do certain things. I break it all apart to its basics so you could see. Okay? And then all these are going to be the same. So you bring half down, -1, bring that down, -1. And that's what 9B, C, and F is about, just the power rule. Okay? So that concludes today's session just on power rule. And hopefully I can jump to chain rule, log, and exponential. And I think hopefully I can squeeze in circular before I go, because I only got about, I think, 2 hours left. Probably not 2 hours left, 1 hour, 1 hour and a half before I go in camp. Yeah, it's gonna be a while. So that's a lot of exercises for you to do anyway, but that's only the one skill, and I want to teach you chain rule. That's the bread and butter. Okay, so if anything, if I can't make other videos in time, chain rule is your bread and butter for chapter 9. If you can't do chapter 9 for chain rule, you're dead with calculus, literally. Okay, just too much to write on there. And that's what I said last year. I said if you're learning chain rule with me, it's the bread and butter for year 12. It is. Okay, But anyways, I think yes, that is it. So I'm gonna end this video and make a chain rule video. Okay, so this is power rule, all power rule practice, 9BCF. Okay, when I come back, I'll be testing that. I'll be making a quiz for you guys to show me what you've learned. Okay. Yes, I will discard.